Hey guys, welcome back. So today we're working on this Generac GP 7500E. The machine appears to be in pretty good shape. It is a bit dirty, but there are no broken parts, no missing parts, and very little rust to speak of. That said though, it wouldn't be here if it didn't have a problem. And the problem is the generator. I'm told the engine runs, but the generator does not produce power. So this machine actually comes to us from a local subscriber, Jay, who picked it up knowing the fault that it had and was hoping it would be an easy fix. But he didn't even unload it from his truck. Instead, he broke out the multimeter and quickly found that the rotor was open circuit. So like that, this machine is never going to make power. So the goal today is to get this producing power again. So let me get you set up a little bit better and get going on this. So first things first, gonna check the oil. I want to get this engine up and running and just at least validate that we have a good engine and see that it's not making power. So we do have oil. It's still in the safe zone, but it's a little bit low, and I'm not really liking the color too much. There's a strong smell of old varnished fuel, so I think I'm going to do something I usually don't do, and that's change the oil before we get any heat in here. So changing the oil, without some heat in it, you're not going to get a great flush. But I've been burned a few times where I thought the oil was at least good enough to test with, and then later, after running the engine, I go to change it and just find out how wrong I am. So this oil, it is low, smells like varnished fuel. So I think an oil change is definitely going to help. Okay, the oil is pretty much full. We're right up to the last thread. So here's an up-close look at the oil that came out. It does not have a good color. It has a very strong smell of varnish. So I'm sure the carb has issues, and we'll have to deal with that at some point. But I'm told it runs in its current state. So let's check the air filter real quick and maybe the condition of the fuel, and then we'll try to start it. Yeah, the filter's not bad. I mean, it's a little dirty, but it's not falling apart. Looks like we have a little bit of grass in there, but it should be good enough to test with. So it looks like the rollover valve is broken. This is just a vent that brings the vapor down to the airbox. So, that is something that should be replaced, assuming we get to that point. As far as the tank goes, there is fuel in here, and there's also some rust as well. So let's get the filter out so we can get a better look at the condition of the tank and the fuel. The tank actually looks pretty good, and so does the fuel. It is nice and clear, doesn't smell bad, and I am not seeing really any rust in the bottom of that tank. So the tank, I think it checks out. All right, let's give this a try. I've got a light plugged in and turned on to one of the legs, And the other leg, we've got the kilowatt plugged in. So let's get the engine started. We'll double check the outputs and go from there. All right, the choke is already on, fuel's on, ignition's on. Well, the good news is the engine sounds really good. You know, it started first pull. I was able to turn the choke off right away. So the engine and the carburetor, they're doing what they should. So I don't think we're going to have to do a whole lot on the engine side of things. But the generator, it is confirmed. It is not making power. That light did not turn on, and the kilowatt did not illuminate. So let's get this machine swung around. We'll get the cover off the generator head and run some tests and just confirm that the rotor is in fact bad. All right, so I'm going to get the AVR out of the way. You know, if we're really lucky, it's just a bad AVR or a bad set of brushes. But those are really the only two things you could fix down here to bring this thing back. I guess the other possibility is that the brushes are plugged in wrong. But in this case, it was correct, although the red fell off surprisingly easy. All right, so let's actually cut the zip tie and just get some of these wires out of the way so we can see the brushes a little better. Now I'm going to test through the brushes. If the brushes are bad, then that could also be a possibility, but let's see what we get first before we take these off. And yeah, according to the multimeter, we are open circuit. Let's just check each brush to ground. So yeah, that is definitely a problem. And I can actually see that the brushes are not even installed properly. There is a tab right there that kind of locks in, or it's like a locating pin to hold the brushes in place. So, I mean, that could be the issue. Although I'd say more likely someone was just troubleshooting this and they didn't put it back together right. But let's get the brushes off. We'll check the condition of them, and then we'll test directly on the slip rings. And I've got you in here a little closer just so you can see better what I'm talking about. So, you know, if we had a good rotor and the brushes were installed like this, we'd probably be open circuit. So there's a chance that that's the issue here. The brushes themselves look to be in good condition. And one thing to check on these two is that the springs are working. Both springs are fine. And I'm going to use the multimeter to measure continuity. When we get a circuit, we should hear that tone. So I'll put one lead here, the other lead on the end of the brush. So we know that brush is good. And we'll do the same for the other. Yeah, so those brushes are good. You know, what can happen sometimes is that the wire between the terminal and the brush can break off. But in this case, they are good. So let me back you up a little bit so you can see the multimeter. We're going to check the resistance next on the slip rings. It should be between 40 and 70 ohms. All right, so I am on both slip rings, one probe on each, and we should be getting a reading, but we are getting nothing. So yeah, the rotor, it does appear to be bad. So without a doubt, we're going to have to pull the stator off. So let's disconnect all the wires. I guess while we're here, we'll check the health of the stator to make sure that that's good, at least. And then we need to get probably the fuel tank off and the exhaust off to free up access to the generator head. And I'm just checking the color coding here. You know, all these wires, they have this white insulation. So we've got a red live wire, and I'm guessing a black. Yep. So those are the live wires, and then these are neutral. I would assume these are white, but I cannot. Yeah, that one's white. And I think I saw white. Yep, those are both white. So the color coding doesn't always make sense, so it's good to note the colors before you get everything mixed up. All right, so I'm going to switch this back to measure resistance like we did before with the rotor. And something I should have done, especially if you don't know the meter you're using that well, is check the internal resistance of your leads. You know, sometimes it can be pretty high, like over an ohm. You know, in my case, it's 0.1 ohms. But whatever it is, you can subtract that from any reading you get to get the true resistance value. So let's start with leg 1 and leg 2, usually around 0.3 ohms. In this case, we're at 0.3, 0.4. You subtract that 0.1, we're now at 0.2. So that seems good. No fault to ground. We can check it also to the other leg. There should be no connection there, which there isn't. And if we want to be really thorough, we can check it to the DPE winding. And there's no connection there. So leg 1 appears to be good. Leg 2, we should get the same reading of 0.3. Then you subtract that 0.1, and we're at 0.2. So that appears to be good. No ground fault. And we can do the same check to the DPE. So good. Leg 1, leg 2, they seem to be within spec. Over here, we do have 4 more wires coming from the stator. Now, these connect into the AVR. The blue wires are essentially the power source for the AVR and ultimately the brushes. And they're called the DPE winding. Usually between 1.5 and 2.5 is what I see, and we're at 2. So that appears to be good. And if we check it to ground, no ground fault. So the stator, I would say, is good. These other wires here, the green and the white, those are just the sense wires, and they usually tap into the main outputs. So we already tested the main outputs. We know they're good. But if we want to double check, then we can go from the green to one of the legs. One of the legs should have a connection. The other one shouldn't. In this case, the red wire does not connect to green, but the black wire does. So that is good. And the opposite should be for the white. We should have a connection here to the red wire and not to the black wire. So the stator, it appears to be good. The rotor, not so much. So we'll get a better look at this once we get the stator off. A lot of times, though, you can see the failure. Usually it's the wire that breaks connecting over to the slip ring terminal. You know, in this case, the wire appears to be connected, at least on this side. So I'm going to rotate the engine 180 degrees. And we passed it a little bit. So right there is the other slip ring terminal. And this side also has a solder connection right there. So that is another common point of failure. And sometimes it's hard to tell, but that one does look connected. A little bit hard to tell down here. We got some fuzz in the way, but nothing obviously broken here. So let's move on. Let's get the stator off. All right, the fuel line's disconnected. This line right here is the one that runs up to the rollover valve. So that is disconnected as well. And just 4 bolts, 1 in each corner. The tank will come right out. These bolts are all pretty loose. So definitely not the first one in here. So although the machine is pretty rust-free, the stator, not so much, but this is just a cover. You know, likely it's the cover that has the rust problem and not the stator itself. So just 4 bolts going around. And we probably want to disconnect this one as well. That is the battery negative cable. And then we should be able to pull the stator off. So a little bit of penetrating oil. There's a ball bearing in here that needs to release from the end housing. And the other problem we might have is the stator side of the bell housing. So the bell housing has a little shoulder, and given all the rust that's here, there could be some rust jacking, so we might actually need to use a dead blow hammer to kind of break that seal. You know, we don't want to use the puller and excessively pull on this because this aluminum piece here breaks with very little effort. And actually, I think I felt things move a little bit just hand tightening it, so I don't think this one's going to put up a fight, and now I can see it's moving. Okay, so with the stator out of the way, we can get a much better look at these wires. Not seeing any failure on this side. Let's rotate the engine. Engine has good compression. So the connection to the slip ring looks good. Right down here, that's a common spot for it to break. But I don't think it's broken there either. So I cleaned off the slip rings. I just wanted to make doubly sure we don't have any kind of connection here, and we don't. You know, if we did, we'd hear the beep. The really weird thing is that these two wires, where they're twisted together, that's the midway point. You have one wire right here coming off the terminal. It goes down, wraps this coil. Then you have the other wire coming off the other terminal, which wraps this coil right here. They come together in the middle. So the really odd thing is that if I probe from one slip ring to here, we get a connection. And if I do the other slip ring to there, we get a connection. But only if I move the probe. You can see right here, we're only, well, now we're not beeping anywhere. All right, so that one we have a connection. And now we have one there too. Oh. So I'm wondering if this is the problem right here. It's got to be. So this rotor, it might be fixable. So the question is, what do we do about this? You know, this wire, although it looks like copper, it's not. It's actually copper-clad aluminum. And I don't have the right tools to try to solder that together, but I'm thinking if we reflow that, what's there, we might actually get a connection back. So I am going to try that real quick and see if that fixes the issue. So I'm going to go on record and say that this is likely not going to work. But we do have options. And I'm thinking if this doesn't somehow magically restore the connection between these two wires, we could probably just cut the wires down there. You know, unwrap a few wraps, get the enamel off the wires, and just make a mechanical connection. You know, these solder joints typically, I shouldn't say typically fail, but it is a very common point of failure on these rotors. So I don't think that is doing anything. Let's just double check with the multimeter. And no, still no connection between the slip rings, but again, if we test up here, we get a connection on the front slip ring, but not the back. If we move the probe, we now have a connection on the back, but not the front. Oh, now we have it on the front, not the back. Now the back, not the front. So yeah, the issue, it's definitely right there. So I am going to cut out this bad connection. And we do have a few wraps around these posts that theoretically we can get a little bit of slack. The problem is, again, this is aluminum wire, becomes quite brittle, and if the wire snaps, then we may not have enough to work with. So there's a few different ways here I can go about trying to clean off this enamel. You know, we could use heat, we could use chemicals, we could use acid, or mechanical means like sandpaper. You know, in my case, I think I'm going to use some heat just to bake that enamel a bit, and then an X-Acto knife to scrape away and kind of clean up just the tip of each of these wires. So, you know, I could use a butane torch like this, but this puts out a lot of heat, and likely I'm going to damage, you know, some of the other wire or maybe the plastic down here. So instead, I'm just going to try a regular lighter where the flame should go up. We'll apply some heat for a bit, then start scraping. All right, so that looks fairly clean. Let's just test it. And yeah, we have good continuity to the slip ring. So I'm going to do the same over here. And then we'll connect the two and see if we get a circuit. All right, so the other wire looks clean. And yeah, we have good connectivity, it seems like. So I'm going to jumper these two just with an alligator clip, and we'll check for a circuit there at the slip rings. And actually, I'm a little bit concerned. The spring tension on the alligator clips is pretty high. But like that, we are somewhat connected. And there we go. So the rotor should work. Of Of course, we need to permanently affix that, but let's just check the resistance real quick going through the rotor. So usually between 40 and 70 ohms. Granted, that's not a great connection we've done there, but let's see what we have. 52 ohms. So yeah, that is perfect. So I'm going to carefully twist these together. You know, there is a chance these wires could break. The aluminum, it's pretty brittle, but as it is right now, you know, this is junk and we have nothing to lose. So let's try to connect them mechanically, and then I'm going to crimp a metal ferrule on it to hold it together, and then we'll use some epoxy to glue it all in place. All right, so that is a nice, solid mechanical connection. Let's double check that the electrical connection is still good. All right, so let's see what we have here. Should be ideally between 40 and 70 ohms. And yeah, we're at 52.3. So the rotor definitely should work. The big concern here is just securing the wire. You know, this spins at about 3,700 RPM, so this wire has to be secured. So I'm going to carefully bend this down and tuck it in here, although first I'm going to clean that up. And then we'll use some JB Weld to just cement the entire thing in place. And potentially could rough up this plastic too to get the JB Weld to stick better. But I'm not too worried about it. There's actually like little like cavities kind of on the left and the right. So the JB Weld, if it works in there, you know, it's going to anchor things down pretty well, I think. Okay, and then I'm going to carefully fold these wires down in here as tight as I can. This is kind of the last big obstacle, you know, bending the wires. You risk breaking them. So hopefully that doesn't happen. All right, that should be good. Let's make sure we didn't break anything. Nope. We are good. All right, so the last time I did this, I just used regular JB Weld. It seemed to work fine, but a few people did recommend that, the plastic weld would be more appropriate because those wires, they're essentially being glued down to plastic on the rotor. So this should be more appropriate, I guess. My only concern is it seems to be pretty runny, and that actually might be a problem. So I may not use this just based on the consistency. I want something that isn't going to drip off. So we'll give this a try. I'm a little bit hesitant because it is kind of runny. But the way the rotor is right now, it's kind of tilted back, so I don't think it's going to drip off onto the slip rings. If anything, it's just going to kind of pool in the opposite direction. I think that's going to work out pretty well. So I'm going to give this some time to cure. And before we put this back together, I'm going to rotate this around. We'll get some JB Weld on the other side, just so that the rotor remains balanced. All right, so now we have JB Weld on the other side. According to the instructions, it only needs 30 minutes to cure. But the longer, the better. And given the amount of force involved here, I'm going to give this a day before trying to get the engine fired up. But there's nothing stopping us from getting the stator back on the machine. At least technically, there's nothing stopping us. Before I do that, though, I do want to spend a second and clean this up. It is a mess and really doesn't match the rest of the machine. This machine is fairly rust-free, but this cover is not in great shape. So this should just slide off, and I'm pretty sure I have some others in the storage locker. So let's try to get this off, then we'll make a trip to the locker and see if we can come up with something a little bit better than that. And the stator itself looks to be in good shape. So for whatever reason, the cover just wasn't made out of good material. So yeah, let's run to the storage locker. I do have other ones that will fit the diameter, but the length might be a little short or potentially a little long. Long would be a problem, but a little short should be fine. Yeah, it's pretty good. 1/4 inch shorter, 1/4 inch less wide, but that should do. Okay, it's been a few hours and it does feel dry to the touch. So I'm going to clean up these slip rings. We'll get the stator and the exhaust reinstalled and then we'll try it out first thing in the morning. All right, so now that we have the stator theoretically installed, we're going to put the bolts in. And I'm only going to snug them up just a little bit. I actually want to get the feet on, set it down first so that we know the alignment is good. Then we'll torque it down the rest of the way. And then I'm going to pull the spark plug. I want to turn the engine over, make sure that the rotor rotates without making contact with the stator. So the stator should get torqued between 80 and 120 inch-pounds. So I'm going to bring it up first to 40, and then I'll finish it up at 100. It might be the original plug, just judging by some of the rust. And it's also a Chinese plug as well, so I'm probably going to swap that out for an NGK. But first, let's pull the engine over, make sure there's no binding. So we'll just start by pulling the engine over slowly. The only resistance should just be the spring tension on the valves. And yeah, it feels pretty normal, so let's try it fast. Perfect. Leave that kind of floating for now until we get the exhaust bolted in here. Then we can snug everything up. All right, we're getting pretty close here. So we just have the wiring, new spark plug, and then we got to give it a little bit more time before actually starting it. So we get the wire block back in, we'll connect up leg 1, leg 2, then we'll connect the AVR and the brushes. And then theoretically, this should make power next time we start it. All right, in this machine, it is neutral bonded, so we had a total of 4 wires connected here. The neutral from the stator, neutral to the control panel, and the ground. So we'll put all those back together. Being sure not to mix that up. You don't want to connect a live wire to neutral or ground. And I've kind of left all the wires loose. I need to get everything situated so that when the cover goes on, you know, the wires are facing the right way. I think that should do it. All right, and the brushes, they are polarity sensitive, so make sure you put the white wire on the right and the red on the left. And those are locked in there pretty good. All right, so we got a new NGK BPR 6ES installed. Now, this plug, I've got to say, I ordered it from Amazon. It doesn't look right. So I'm willing to bet this is probably a counterfeit NGK. It's probably the same brand that I pulled out, but at least it's new. And I'm going to have to find a better source to buy these plugs from. So we're all back together. We've got everything ready to go. Even got the carb fueled up. So in the morning, I think first thing I'm going to do is crank this engine, and hopefully we see that light turn on. All right, it is the next day, so it's the moment of truth. Will the generator make power? So we have fuel, chokes on. Let's try the electric start. So I would say the repair we did on the rotor did the trick, because this time the light came on. We were pretty much exactly at 120 volts. The engine speed though was a little slow, so we adjusted the spring tension. We're now at 61.5 hertz, no load. So the engine and the generator, I think they're good to go. So let's repair the rollover valve on the tank, and then we can get that reinstalled. So there is really no easy way to get this valve out. You know, a lot of times they loosen up with age and quite often leak. So I actually have one of these valves that I ended up not needing for another project. So, you know, these valves are fairly universal. It's just a little shoulder, you push it in place and then it theoretically makes a seal and stays. This one is a pretty tight fit, so definitely going to be a challenge to get this one out, I think. You know, the important thing is just go easy. You know, you don't want to cause any damage to the tank itself. The valve doesn't matter, it can come out in pieces. But there is fuel and fuel vapor in here, so you don't want to do anything to make a spark while getting that out. Okay, that actually wasn't too bad. And now that we have that opening, I'm just going to get a better look inside the tank. Make sure we don't have any rust or water in that fuel. Yeah, it's a good thing I did take a look in here. If you look on the right side of your screen, you can just see what appears to be a pretty well-defined water line. So we need to get that out, and since the rollover valve is removed, you know, we'll just tip the tank upside down to get the contents out. Actually, there is a lip going around, so we're not going to be able to get all the water out tipping this upside down. So instead, you know, let's remove the valve and we'll just dump it out that way. It's a good thing we got that fuel out of the tank. The fuel isn't as in good of condition as I thought, and of course the water will destroy the tank. Now, the water, it is actually kind of hard to see because there is so much of it, but if I tilt to this, you will see a line form. So you can kind of see it there in the center of your screen. And of course, the more I tilt it back, that line of water moves further back. So yeah, there was quite a bit of water mixed in with the fuel. Okay, new valves installed. I was going to say it's nice and tight, but that's about how tight they normally are. So that should be good. I guess we do still have the piece right here. That is, the broken piece from the old valve. So we need to get that out. Probably just like a wood screw, and then we can pull that out. No. It's too petrified, so let me see what diameter this is and if I have anything appropriate to take its place. Yeah, it's about the same. The problem usually with this is the outer diameter, but it looks like this is going to fit through these hold downs. So let's see if we get a snug fit here on the valve. Gotta be really careful with this valve. The barb breaks pretty easily. Yeah, and this line, I think it will go on, but it does need a little heat. But since it's not petrified, I think heat will make the difference here. good enough. All right, so we'll get the valve back in. I did clean off the filter and also just drained the sediment bowl since there's a chance there was water in there. And we should probably pull the plug as well on the carburetor. Just drain the bowl, make sure that no water made it into that carb. All right, I'm making an executive decision here on this. When tightening it up, it did not feel good. And this nut is supposed to spin free of the valve, and of course this one's not. This is a brand new one. There we go. So you're supposed to be able to spin this separate from the bottom half, and this one was not doing that. And when I cranked down on it, I thought I heard the filter crack or something crack. So we're not going to chance it. We're going to put a brand new one in. Because if we don't do it now, we're going to end up having to do it later. So the only possible complication here is that these usually take 3/16 fuel line. That's what Honda clones use, and this is basically a Honda clone fitting. But this output here looks to be 1/4 of an inch. So we'll have to take a closer look at the carb, but usually carbs like that are also 3/16. So I don't think we're going to have an issue there. But before we bolt everything down nice and tight, let's get this loosely in place. We'll check out the fuel line situation and just make sure this is going to work. So let's get the airbox cover and base off. I want to have access to the fuel line where it goes into the carburetor. And just looking at what's on here right now, it should definitely be replaced. There are a bunch of cracks going around right there. So that line is no good. And there's also a fuel filter here too, which we don't really need. The tank has a pre-filter, and there's also a filter where the fuel comes out of the valve. So 3 filters, unnecessary. Okay, good. And that is a 3/16 coming out of the carb. So we can just run standard Honda clone fuel line, 3/16 ID, and we should be good. So I'm going to spend a second, just clean this up. Now's a good time to just pull the drain on the carb, make sure we don't have any water in there. That was already loose. And that bolt is nice and clean, no varnish. So chances are the carb is in good shape. And the fuel that came out, it is a little hazy. There might be a little water in there. So I'm going to set that aside. Actually, I can see a little water line forming down there. So it is a good thing we drained it. So that would have caused run issues and definitely damaged the car, but I think we caught it just in time. So this filter, it's still usable, but it's definitely well past its prime. So I do want to replace it. I don't have any currently to put in here. So I'm just going to make sure it's as clean as can be. Get a new one ordered up. But this should be fine for now. All right, and last but not least, these wires have to be secured. There is enough slack that they could get sucked in and wrapped around the rotor, so you do not want to leave this unsecured. And I'm going to add one more zip tie for good measure. That should do it. All right, so what do you think? Is the JB Weld gonna hold? I think it will. You know, the bigger question is, can the engine actually pull 7,500 watts? You know, 7,500 is the absolute best this engine can do if everything is running perfect. So we're gonna find out in a minute, you know, if the engine and the generator are up to the task. But before I do that, I actually did get a new air filter. So let's get that installed real quick. You know, once that's done, we'll get the engine started. And while it's warming up, we'll double check the outputs, both the hertz as well as the voltage, the total harmonic distortion, and also take a look at the sine wave. If everything's good, we'll put on a 3,000 watt load, let that run for a bit, and then we'll go for the max of 7,500 watts. So hopefully this filter fits. It is an aftermarket filter, and it's a little larger and thicker. It was advertised as fitting this machine, so let's just see. Yeah, I think it's going to be okay. So we do need to oil this up. You know, foam filters need oil to work effectively. And for generators, that actually may not be a huge concern since they don't usually run in dirty environments, but it can't hurt. So we'll just work that oil in, get the excess out. And I guess the other wild card here too is the carburetor. You know, that carb, don't think I cleaned it. And usually that ends up biting me, so hopefully that's not the case here. All right, no issues at all getting the machine started. Without a load, we're at 121 volts. The engine speed might be a little slow at 60.5 hertz, so likely we are going to have to bump that up. And I suspect once we start putting a load on, you know, we're going to see that engine speed drop below 57 hertz at some point. And if that's the case, we'll take the load off and make some adjustments. So without a load, THD is pretty good at about 4%, and the sine wave is a little choppy, but fairly typical for a machine like this. So let's turn on cooling fans, and we'll start with a 2,000 watt load. No issues. Let's try 3,000 watts. Yeah, engine speed is holding quite well at about 60 hertz, maybe a little bit above. THD, though, did come up quite a bit. to 15.2%. And the sine wave cleaned up a little bit, but now the shape is also a little bit deformed. But so far so good at 3,000 watts. So we'll give this a few minutes, and assuming everything checks out, we'll go for the max of 7,500 watts. Alright, no issues at 3,000 watts. The engine speed too held pretty well at 60 hertz under almost a half load, so that is very good. So let's bump it up. Let's take 1,000 off, replace it with a 2. So now we're at 4,000 watts, no issues. How about 5,000, 5,500, 6,000. So yeah, no issues there. We'll bring it back to 6,000. How about 7,000? Yeah. 7,500. So it's actually pulling its rated load, and we're at 18.9% THD, and the sine wave looks about the same. So let's give this a bit of time, make sure there's no surprises, and then we'll shut it down. Alright, not too bad for a machine that was basically junk with a bad rotor. So we pulled the 7,500 watts. Both the generator and the engine had no issues with it. So we'll give this a few minutes, let the load bank cool down, as well as the engine and the generator, and then we'll shut it down. Well, I think we made out pretty well. We didn't even have to clean the carburetor, and apparently we didn't need to because the engine had no issues at all pulling its rated load of 7,500 watts. And the generator also did well. You know, I'm always a little hesitant to make repairs like this, especially on cheaper machines where the generator from the factory really wasn't meant to last. You know, it was built with copper-clad aluminum. You know, if those wires had been secured properly, they wouldn't have failed in the first place. So my hope is that the repair I made will outlast the original, and with any luck, it'll last the life of the machine. But that's kind of the gray area. I don't know for sure how long this is going to last, and I would feel pretty bad if this ended up failing on someone else. Anyway, let me know in the comments what you think of this repair. You know, given the tools and supplies I have access to, would you have done it differently? Or is there something better that I could do here? So, I hope this video helps someone. Thanks for watching.